Okay, so are you all good with the dark theme, or I should change to the light theme?
I'm good with the dark things.
Okay. I think I should show you how the dark theme looks, what it looks like, something like this.
No problem. I use dark thing.
Okay. Mm, okay, so let me quickly do this thing. Okay. Um, in our previous class, we were building a task manager with Express and SQLite. So we actually designed our application. We integrated a database. We created our server. We added NodeMon, and we implemented the MVC pattern. Then we started adding some CRUD operations, but we did not finish with that one. So I think that's where we stopped. And before we continue, let me just explain some things. I think we'll do a recap on something here, on the middleware and all of that. Let's start with our index.js file. Here we have about 1, 2, and 3. No, 1, 2, 3, and 4 application level middleware. And this is self-explanatory. We're not going to be explaining this Express.json because it's built in and we already know what it is. And we already explained this task. We're using our task router. And then we are adding, should I say we are prepending the route with task, something like that. You can even say task / something else, and it will be recognized. Or we can even say task / with no task, that is the index route, but we don't want that. We want something descriptive, tasks, so that if you visit our domain /tasks, then you get access to all our tasks. For now that we've not added any authentication or authorization. Then the error handler. If at all we visit any of these, or we try to create a task or edit a task, I will get any error. Our error, this async wrapper, we propagate this error to the error handler, and then the error handler will handle it to us. This async wrapper will pass this error to the next function in our middleware stack with the error as an argument. So the next function in our middleware stack is the error handler. As you can see, it is accepting these parameters, the error parameter that this async wrapper is passing to it. It's passing this error, and the error handler is accepting it here as well. So if you check if this error is an instance of our built-in error that we extended to custom error API, it will return a response with the status of error, the status code, and then with the JSON object of message, error message. But if it's not an instance of a built-in error object, we simply set the status to internal server error, which is 500, and then a message of internal server error. And we have another middleware, not found. And this next is not useful here because this is where it will terminate. We're not propagating these errors to anywhere else. Okay, so inside this not found function, we're accepting the request and the response. And this is the last function in our middleware stack. And if no route matches, if the route you specify doesn't match any route in our application, then this middleware will be called not found. We trace the status code of not found, and you send back route does not exist to the user. Okay, and this async wrapper here may be a kind of confusing, but this is a JavaScript thing. It's not specific to Express.js. This is a higher order function that takes in another function. Then it returns a function with request, response, and next. Then it calls this function here, this function that we passed in as a parameter, and then it passes in this request, response, and next parameters here as arguments. Then it calls this function with this argument. Then if there's an error, it propagates the error to the next function in our middleware stack with the error as an argument. And that's all this async wrapper does. And what we're trying to simplify here, we're trying to avoid handling errors in each and every function in this in our controllers function. As you can see here, we just implement this without writing something like, let's say, try catch, and then we'll do something like this. Then we'll come and handle our errors below. No, we're not doing that, because that is automatically handled in our async wrapper here. Now try catch, this function here, this function, this one inside, is already in our try block. It's already called in our try block. So if there's any error, the error will be propagated to the async, to the error handler to handle it to us. So we don't need to write any try catch. That's handled automatically in our async wrapper. And that fn we pass in as a parameter is this very function. And that's the reason why we're calling it with the parameters of the request, response, and next. Anywhere we need next, we call it, but we don't need next here, because the next, we're only using it to propagate error to the error handler. So we don't need next here. That's why we're only utilizing the request and the response parameters passed to that async wrapper function. Okay, so that's it for the async wrapper and error handling. We simplify that, because in a case where you have a very large application and you want to simplify work for yourself, and that's what you basically do. Okay, that's it for that. And what next? We implemented create task, and we are left with edit task, delete task, and then get task. We also implemented get tasks, where we fetch all our tasks and all of that. Okay, so now let's start our application. npm run dev as usual. Okay, application is running. Okay, now we'll come here and we'll say something like cd express task, like so. Now we're inside our express task manager. We say npx prisma studio. npx prisma studio. I will just, and the Prisma Studio is running on localhost 5555. Okay, so simply what this is, this is our database. You know, we cannot open this SQL file. Where's Prisma folder? Prisma. Okay. We cannot open it in VS Code, and our database is not hosted anywhere. It's hosted right here in our application. So we need to see what's going on in our database. So you just, after running your application, you come, make sure your application is running first. Then you come here and run npx prisma studio, and then you see environmental variables loaded from .env, prisma schema loaded from prisma/schema.prisma, and then prisma studio is up on http localhost 555 and that. So if you go to a browser, you can see we have 1, 2, 3 tasks, and they are not completed. We have false. Okay, it is Okay. Used to filter our tags, showing fields, filter, and all of that. If you come here, we'll have just a single model, which is task. We've not added open a model. Maybe you search for a model like so. And we only have tasks, so we don't have any other model, but this will be helpful. We help utilizing, visualizing our data, the data in our database. Okay, so now let's work with getting a single task. And our request has so many properties. It's an object with so many properties. It has the body, it has the params, it has many other things. In fact, let us log the request in this get task request and then try to check it out. And then we'll come down to our postman. Okay, I think we're handling this correctly. In our route, get task /ID. Okay. So come here, we'll log our request. If you want to send, let's come here. I think I need to copy. Okay. I need to copy an ID here. Then come back to postman. Then say task / the ID of the task. And then we change this to get, or making the get request. Then we send. Okay. Hello router from controllers. Yeah. And then we will see our request object. It has a bunch of methods and properties. Oh, God. Much, so much properties and methods. Can you see this? Oh. This is too much. And we're not even using up to 1/4 of all these properties and methods because they're meant for different symbols. We're using symbols here. The original URL, which is /task/ the task ID, the base URL, which is tasks. And this is what I'm actually looking for. And the next function is the middleware function, of which we're not using. Auth, node, host, node, port, node, hosting, node, and all of that. We'll have the path name /ID. We'll have the path /ID. We'll have the href, hypertext reference /ID. We'll have the raw /ID. I have the params. Yes, the params. We have params here, which ID is this, and then we have the query. The query is actually an empty object because we will take a look at the query in a short while, in a second. We'll have the params, and the params has an ID of this. The response is actually an object, server response with all these writable true, destroyed false, chunk encoding false, should keep alive true, and all of that. Chunk encoding is false because it's HTTP and not HTTP secured. Okay, then we have our params and our query. So our params contains an ID of 7 and then we have a query. Then we'll take a look at the query in a minute. For now, let's deal with our, okay, I think I need to clear this and then restart our application. For now, we have the request. Then let's see, we'll say we want to request out params. Oops. Now we'll send this request again. Now we want to log request of params. Then we'll send it again. Then let's check what we've got in our terminal. Okay, we got params is an object with an ID of the ID we just sent here because we want to fetch a single task with a given ID. So what we will do here, we'll come down here and we'll say const ID is equal to request.params. Or this, there are different ways you can get this ID. You can say const ID is equal to, you can get your parameters from the request object. Then inside your parameters, you can get your ID. Oops, you can do something like this. You can get your ID, but this is not ID or crashes ID params. Unexpected token. Yeah, this is an object, like so. Or what am I doing? Params. Let's leave it this way. I don't even know what I'm doing here. Getting myself confused. Okay. Now ID is equal to request of params. Then let's log our ID to see what we got, and let's send this request again. Okay, and then we got request of params. Okay. We destructure the ID from the objects, from the request object. Or if you don't want it, like, I can leave the ID like so, and then say request of params.id. Or if you want, you can destructure this ID from the params object like so, like this ID. Like so. And now if you send this request, send the request again, what if we will see our ID. Okay. So now what do we want to do? We want to fetch a single post by this ID. Yeah, thanks for that. We want to fetch a single post with this ID. We say const task is equal to await database database task find. Since we are finding by ID is unique, then you say find unique. You say where ID, like so. We can say where ID is this incoming ID. But since the ID in our database and this ID are identical, we just use the ES6 syntax ID, like so. And then we'll say, we'll send back the response of status codes dot OK JSON task, like so. Okay, so now let's see. Let's send this request again. Wow, and we have our task here, the ID of this title testing, descriptions on testing and completed false. And then if we go back to our Prisma, we'll see testing, some testing completed is false. Then let's get this ID as well. And then come down here and try to get task given ID. And we have task create task function, test function. Add unit test to create task function in controllers and completed is false. Okay. And this one is working. Yes, it's working. Okay, so let's do something like this and then make this request again and see what you've got. I think this error will break our server. Okay, where undefined params. Oh, I think I should come to the route and change this to I. And then see what will happen. See, the server is here. way of typing as an argument. Okay. I'm just trying to cause an error. Error. That's an intentional error. Okay, let's see this. If you get what we're looking for. Okay, so what is it saying? Error. Okay. So, but this is not the kind of behavior we want. We want these errors to be displayed correctly. So in this case, I think that's why we need a package known as express async errors. I think I'm spelling it correctly. Let's see, MPI install express async errors, something like this. It will handle and format the errors for us correctly, the way they should be. Okay, I think it's like that. Then after installing express async errors, we come down here and then we import express async errors, like so. Then let's start our server. I think this should work. Okay. Then let's send this request again, see what we got here. Aha. And saying error. Okay. Now our application is not breaking, but then this error here is not correctly formatted. Okay, so what's happening is supposed to propagate the error to our error handler, the error, the request, and the response. Okay. So let's go back to application. Then let me try something else, like return. No. It's not return, it's throw. And like so. This is 39. Okay. Oh, thank you so much. Oh, we actually forgot to wrap it inside async wrapper. Thank you. I think it should work now, as expected. Okay, we'll send it. Okay, now let's throw the error and see. No, throw new error. Like this first. Okay, send the request. See the same thing. But then error. Okay, error. Some error. There's no message in error. Send the request again. Have an error. Internal server error. It's returning 500 internal server error. But then the message is not correctly formatted. And some error. The message is here, some error. But then our application is not breaking. That's the most important thing. The application is still running without breaking. Okay. So let's do this here. Let's make it an ID. And then let's make the request and see what we've got again. got an error. Reference ID is not defined. Then we'll come here. So reference error ID is not defined. Okay. Okay. ID. Like so. Okay, maybe we'll format this later, but now I think there's a little mistake somewhere. And then let's add this async wrapper to all of this so we don't forget again. Like this. Then the delete. Okay, what's this? Async wrapper. Right, so so the next function we're going to be implementing is the edit task. So we get a function by the function's ID, and then we modify we get a task by the task ID, and then we modify the task. Either we want to set it to completed, or we want to edit the description, or anything we want to do with it. And it's the same thing here. We say const ID is equal to request params. Then we'll say const task is equal to await database task. That's the name of the model in our Prisma schema. Our Prisma schema. That's find task updates. We're not using upsert. Upsert here is if the task doesn't exist. If it does not exist, it will be created. Then update here will simply update your task. Then we'll go like where ID, the incoming ID, and then we say data, what we want to update. Then we'll select any field you want to update. And we'll say completed. No, we'll get the request.body as well. Request body. Say let's say update task is equal to request body. And then we say the data is the request body. There's the updated task. Update task, data update task, like so. Or you can say data completed. You can set it to false if you want to do it like this. But if not, you can do something like this. Then you see request.body is actually an object. Then you can say update task, which is an object, like so. You generalize it so that if it's a description you want to update, only the description will be updated. If it's a completed, you change it to true, it will be updated instead of updating individual fields. Then you come here and say response status codes. Okay. JSON should we say JSON task? Like so. Or you can even say task and then say message task updated successfully, like so. And then you can even do this for every other thing. You can say and task created successfully, the message, so that the front end developer can utilize this to display better UI messages or something like that. Okay, now let's try to update the task and see if it's actually working. Okay, now in updating a task, go to patch, and then we want to update this task, and we want to change, we'll go to the body here. And then we want to change the description to add unit test to create task function controllers. Then we change this to add unit tests. And let's send the request and see. Okay, response of 200. And then we have our description, add unit test, and the title is still test create task function. Okay, now let's change the title to add test to, change the title to add unit test to create task function, like so. And then we send it again. And then we have the title, add unit test to create task function, but the add unit test, the description completed are still the same. And you know, we can't modify the ID. The ID is a unique identifier. If you try to modify it, Prisma will throw an error. Okay, so that's sweet. Our update task is working. And we can do something like, let's do away with this and they say completed true. And then we'll send it again. 200, and we have completed true, and we have our message task updated successfully. Then we have completed true, and that's sweet. Okay, and we'll go to, want to delete our task. The same thing, we get the ID of the task because we can find the task by its ID and then we delete it. What you have to pay attention to is how we're using Prisma. Here, we want to fetch all the tasks. We fetch tasks, go to our database task of find many. Find many, that is to fetch all, to find all. And then, but you can specify, we later add some arguments to this find many function, how we can utilize it very well. And then inside of the get task, so how we're getting the ID from the request parameters, and the create task, the request body, and then the edit task, we're getting the ID and the request body as well to edit our task. Now we want to delete our task. How do we go about deleting a task? All of that. Okay. Now let's see, we have const ID is equal to request params. Let's see, const task is equal to await database task delete where ID, like so. And then what we want to send is rest status code. What is the status code for delete? Status code, no, it's still 200. Yes, okay. Send task deleted successfully, like so. And then, or we can, or like so, let's just remove this. We don't need to send any other additional information to the end user. We just want to send this. Okay, now let's try to delete this task we have here. Let's change this to delete, or is it delete? And then we don't need the body. All we need is the ID. And then we send task deleted successfully. And this is sweet. This is sweet because our application is working as expected with no stress. Everything is being handled. And it's well organized. You can take a look at the folders. We have the routes, the utils, we have nothing in the utility function folder, but then it is good to organize your project like this so that it will be easy for other developers to work with you on your project. And later on, if you want to navigate your project, or you want to add more features, or we're going to be definitely adding more features to this application, like authentication, authorization, and all of that. But then for now, what is next on our list is sorry about this, server deployment. Okay, now I want to teach you how to deploy our server. I'm going to be using Cyclic because it's difficult nowadays to find platforms where you can deploy your server code for free. And one thing about Cyclic is even the free tier it's always running. It does not sleep. You know, some free tiers like Heroku and other hosting services, the free tiers normally sleep. If you don't use it for 30 seconds or 1 minute or so, or 30 minutes, it will sleep. And if you want to make a request, the first request will not be successful. The first request will have to wake the cluster up, or the container, or whatsoever, how the architecture is, I don't know. But then the first request will have to wake it up, and then it will fail. Then if you make the second request, by then the server will be up and running, then your request will be successful. But first of all, what I want to do is we're going to be using a query, request query. Okay, so now let's come here and then log request query, the query object. Okay, so now we'll come down here. We'll remove this ID. And then if you come to your Prisma, okay, where is it? I think I should move this down. Come to your Prisma Studio, and then maybe you refresh. Okay, then we have 2 tasks in our database because we deleted one. Okay, and then if you come here, okay, we've deleted this one already, then we send. Okay, I want to notice something. Prisma task deleting option, because it depends on one or more records that we required. Okay, now let's try something, because we've sent the request twice and we're getting an error because the delete, I think the delete method is it idempotent, they call it. It's a kind of terminology in mathematics where things don't change even if you perform operations on them twice or something like that, specific to numbers. But then it's also used in computer science and in programming to be specific. So let's do something like dot then. The catch, we want to catch an error even here. Error. Okay, now let's log this error, because we want to handle this delete if at all a user sends the request twice. Let's see what we've got here. You can see the task is deleted, but we're getting task deleted successfully, and we don't want that. Okay, now we have an object with the code of P2 SOTO client, and then meter with cause or record to delete does not exist. Okay, so what we've got here is then we'll say error meter. Let's log the error meter and then see again. And then, sorry, postman, send the request again. Then let's come to our terminal. See, we have the meta is cost, record to delete doesn't exist. Okay, so now let's go back to our code. Let's simply return error meta. And you know how arrow functions work. We just return it implicitly like error meta. If there's an error, we catch the error, then we return the error meta object. So now what we do here, we actually return a JSON object like so. And this is proper error handling because a user might be sending requests 1, 2, 3 times to delete an object, a task. The task is deleted, but it's still showing the user task deleted successfully for like 5 times, and the task has already been deleted by the user. The first request the user made. So what we want to do here is we say data is if, okay, first of all, let's say task const task is equal to await like so, and then let's log task and see what we've got. Okay, send the request again. We've got an empty object there, yes. And then here we have course. Okay, this our task is this. Okay, what we want to do now is you say data. If there is a task with an error object, then we want to say we want to return the task error, or if this is task error object with a meta, you want to return task error meta cause. Else we say task deleted successfully. And this is a JavaScript thing. Okay, so now let's send the result, the request again. Let's remove this. And this one here, I think I'll move this back here. Okay, now we'll send the request again. Data task. Oops. Oh, I think I've made a mistake here. What did we get initially? Sorry, please. I think I made a mistake. Task. Okay, we're already returning the error meta. So task meta. And then we'll do like this. Task meta course. Okay, now we'll send the request again, and then we'll see. I think. Okay. I'm down here. Course. Okay. Task meta. Data. If this task course, and then we say task meta course. Sorry, like so. Okay. I think if there's a task, remove this meta. Let's send the request again, then see what we've got again. Okay. Record to delete does not exist. Okay. I was just making a silly mistake here because we are returning error meta. So the course is in the meta object. So we're passing it to the task. And then if the task has the course object, then we want to display the task, the course object to the user. Else, if it does not have any error, that means the task has been deleted. Okay, so now let's try deleting another task and then see how this works. If it's working as expected, then we'll come here, we'll copy this. Then we'll come to Postman. We'll replace this ID with the one, sorry, here. We'll replace the ID with the one we just copied. like so. And then we send the request. Which one did I just copy? Did I copy anything? Okay. Post node. Did I delete the? Okay. The last one. I think I already deleted that one. Come here. Like so. Then we paste it. Send the request. That's deleted successfully. Then let's send it again. Record to delete doesn't exist. Oh, and this is the behavior we want. And we've handled errors correctly in our application, and it is sweet. Okay, and you can do, it depends on how you want to handle your error. Just use this as an example, because there are some of these functions we've not handled errors properly. What if a user sends in an ID with no body, with no task body in the edit task or create task? And we have to handle that as well. So I will leave that to you to be able to handle that on your own. You check for the request body, the description and title. If there's no title or description, you throw them an error. And then later on, we'll see how we can validate inputs with Express Validator. But that's in our subsequent class. For now, I think okay. Now we want to make use of our request query. Let's send a GET request here. Let's remove this. Where am I taking my cursor to? Okay, then let's make a GET request here. Okay, we don't have any tags because we've deleted everything. And then the request query is the request query object is empty actually. See here, we don't have anything. We deleted all our tags. Okay, now let's come back here. And then in our params, we're not sending in any params, query params. So let's say we are sending in, we want to see where our task that is completed. Okay, but before we put in there, let's just see how we can do it manually. If you want to send in any query parameter, what you will do is you just add a question mark and then you say completed. Let's say we want to filter our task where the completed is false, like so. As you can see, as we're updating it, look at what is happening here. The query params, the key and the value, it's being updated automatically. And then we want to say, we want to also send the title of I want to send Q. Let's say Q is equal to title, like so. And then we say and, we add and here. So we now have two query parameters. Okay, so now let's send this again. And then let's check our terminal and see what we've got. Okay, we have a queue of title and a completed of false. Okay, now let's come back and remove this queue of title and let's leave it empty like so. And then let's send the request again. Then let's check our terminal. As you can see, we have a query of empty string and a completed of false. Okay, so now we want to change this completed as well. We want to leave it empty so that a user can pass in false or true. Then send the request again. Then if you come down here, we have query to an empty string and completed of empty string. Okay, so that's it for that. Now we want to handle this. Then we'll say const queue and then completed is equal to request query, request query. And then we want to make, this is where we make use of the request query in our find menu. Then we'll add an object in our find menu function. And in our find menu function, this object is, we'll add a where we want to find many tasks, but how do we want to then filter them? Where? Or this is the Prisma theme, or an object title, as you can see, also completed. Then another object contains what? It's a query, right? Contains Q, the query we're getting our request params. And then the second object here, we have completed. And then we set it to our completed, like so. Okay, so this is filtering. So right now we want to, let's add like a bunch of, let's change this to post. And then let's do away with this. And I'm using just a single, what should I call this? A single request here, because I want to make things faster. Later on, when we get to API testing, we'll explore Postman and how we can add environmental variables. If you want to add environmental, you can just highlight this and then set as environmental variable. Then the name is base URL, then you can send lookups 3000 or something like that. Anyhow you want to do it, so that if you add another request, you don't have to come back, okay, base URL. Then if you come here, what is the base URL? Press is 3000, so you can just say /tasks, like so. And then if you send tasks, then if you come here post, then let's go to our body. And inside of this body, we want to send a title of task 1, then description. Sorry, description. Description, JSON format. And you say, this is task. This is the first task. Then let's just send it to first task, so that it will make our filtering more descriptive. First task. No. I don't want to save it. Okay, then we'll send the request. Or getting an error. Your status is not a function. Post tasks. Status not a function. Create task. Status to created JSON task. Error handler. Status not a function. Okay. Create task. New task. Create body. Request response. Task or database task. Create data. New task. Post base URL. Current task. Initial. Tasks. Title description. Internet server error. So what happened? Create task async wrapper async request response. Body. Okay, let's log our request body. New task. And then send the request again. See down here we have error handler. Error request response. Status. Internet server error. Okay, so what's happening in our create task function here? Create data, new task. Press, yeah, status, looks good. Type error, where's your status? It's not a function. In our error handler, raise status, GC. Environmental variable. Okay. Here's URL. Okay. No, here. Environmental variable quick look. Okay. Edit. Let's edit it and make the initial / tasks like so. No. And then save again. Tasks. Okay. Now let's send the request again and see. See the error. Rest status function. Error handler. Layer handler. Yes. Okay. Someone wants to say something? You can go ahead.
Okay, I think since we have prepared the append the task route to the base URL, so we didn't need to put it in the URL box in that Postman URL box. We didn't need to put it there again.
Oh, it's true. And I saw it because if you check the environmental variables, you have the current value is /tasks. And let me edit this like so. Okay, I was supposed to look at the current value. I was looking at the initial value and I even made a mistake there. So, okay, so let's make the request again and see if it will work. Okay, thank you so much for the correction. A silly mistake from me. Okay, so that is our first task. We change this to second task. And then this is the second task. Then we create it. Then we change this one to third task. This is the third task. Create it again. Okay, let's check our Prisma Studio. What do we have in our Prisma Studio? Okay, we have 3 tasks. Okay, now let's try to filter them. First of all, we'll modify like let's say 2 tasks. Then we change it to completed true. Okay, now let's come down here, copy this ID. Now we'll change just a single task because we have 3 tasks. And then we'll say slash this, then we send. And then below we have our completed true. Okay, so now let's go back to get, then remove this ID entirely. Then get back to our params, take this down. And then we want to add Q. We want to give it a value of first. And then we come here and they say completed false. And now maybe we may not get a task because the completed, the first task is set to true. Then let's make the request and see. Okay, we're getting an error, internet server error. And it's saying invalid Prisma task find many location. Prisma. Wait, or title first. Completed false. Argument completed, invalid value. Okay. We're providing a string instead of a Boolean. Okay, so how do we do this? I want to completed. Okay, so now let's send our request again. Okay, so we're using or. Now let's see, we're using or. That means we want to get the task where either the name is first or the completed is set to false. So here we have completed true, but then the name here is a first task. There's a first in the name, as you can see. Okay, we can even do something like that. We can reduce this to FIR, and then we'll send it again. And this FIR in this name, that's where the includes, how the includes work. It's very, very efficient in filtering items from the database. So we can even change this one here to, let's say, true. Completed true. And we still have the same task. But then if we go here, we have, let's say we have second. Let's send. Okay. We have two tasks with a second and first because the completed is true. Here we have this the second task here, the name, the second in the name, but then the completed is false. But we have another task that the completed is set to true. So we are getting it like so. Okay, and you may want to check, we may want to leave this empty and send where to get this one. If you send it, Boolean. Query second, okay, Boolean. What's happening here? Like so. Okay. Then we got our task. Third task false, second task false. Query second. And where is it returning? Second and third. I think seems supposed. Okay. We're using Boolean here. And there's a problem with this Boolean because if we don't pass in any value, then the Boolean completed will be false because it is an empty string, or it will return undefined or null, and then this Boolean will convert it to false, and then it will search for task where the completed is set to false. So there's another better way we can do this, and then I think I should leave it up to you or some other time. But then now I'm focusing. Let's change this to and. And in this and, this if we come back here and then we set this to second, then we change it to completed true. We may get an empty array because the second task is set to completed false. You know how the or and work in computer. This is the same way this here is working. Okay, completed false. The second task in our list here. Sorry. Let me rephrase this. the second task completed is false. So, okay, and another problem we're facing. Now we have a string. Now this Boolean is converting this string to, okay, so what we will do now is, okay, let's go with this. Let's see if it works. Now we're learning. Okay, see, it doesn't work. Okay. Okay. I think there's a way to do that. I think I've forgotten. Okay, it's working now. Okay, now let's change this to true. Send. Send true, then still inverting it. Sorry, I'm wasting time on this. I'm just trying to figure it out or something like that. Pause. Okay, that's it for that. I think it's a way we can do this, but then I think for now we have completed here to the first way. We'll talk about that later. We need to convert this string to a Boolean. False string. Okay, or we use the or, and then the and, where let's change this to completed and make our request. Okay, false, true. We're using or. Okay, that's that for that. This is how to filter your, let's say you want to filter where only the completed task will be returned and then only the title that contains the query string and all of that. Or if anyhow you want to filter it, you will just do it. And in here you can even add a comma and then add and another array and then go with some other this thing. Or you can even write it in a separate function and then include it and then call it here. Anyhow you want to do it. But that's it. Okay, so for now, what we will do is we'll stop our application. Then we say add, then we commit it to GitHub. Then we push it. Okay, now let's come back here to, let's move this over. And then let's go to cyclic sh. Move to cyclic sh. I already have an account with cyclic, so I will simply log in. And it's taking a little bit of time. I will log in with my GitHub account. I believe we'll have GitHub accounts. And then log in. Okay, so I have one project in my Node project that is hosted in the job portal API that I built some other time. And a friend of mine requested so I can deploy it and he can make use of it to test his applications. Okay, now I want to deploy. So I have a, and if you should just, I'll create this deploy now. And then this bar here, this tab, I will select the link your own and button. Then I will refresh. After refreshing, I see all my repositories here, and they are many. Okay, so which one do I want to really? I want to use the KodeCamp 3. I want to connect this repo to Cyclic. Go to advanced. The root part here should be, because our project is inside of the repo. So I want to choose our project. And where is it? Okay. And the branch is not main. Let me choose the branch. The branch is Express Task Manager. That's where our application is. And then I'll come here. Now it can load correctly. And I have an Express Task Manager. Good. And then I will connect to Cyclic. And after connecting, you will notice something. Okay, our app. Now Cyclic is building our application. NPM 10.1, Node version 18.17. The runtime environment is Node version 18.x, that is 18 above. Then they are deploying our app. Then we are live. But there's a problem with our app. If we click this URL, let's see what we've got here. Error. Type error status is not a function. Okay. Let's go to /test here. We're still getting the same error. And let's come back to here. Let's go to, I want to show you something. Let's go back to KodeCamp 3. No, not the, where are my applications? Go back home. Okay, KodeCamp 3. Click on it. Then click on logs. It's actually listening to a request. So let's make a request. Logs. We have an error handler. Error status is not a function. Server running on port 3000. And this is happening in production. Error status is not function. Yes. We don't expect that to happen. Okay. Let's start the application here. Then make a request. /tasks. And it's working. Then come back here. Oh. That's true. Making several mistakes. But then even if you set our environmental variables here, the variables here, there will still be an error because SQLite is not supported in production. So I prepared something here. Let me quickly grab I have something here for testing, and I don't want you to see it, a MongoDB URL, and then we'll come here to our database, our schema. Then we change this change this thing to MongoDB, and then it will tell us that, oh, MongoDB does not support those kind of IDs. So we'll remove this thing. Just pay attention here, and then we'll say at map ID. We are mapping this ID to the MongoDB ID object, ID.object ID. Okay, like so. So if you're using MongoDB, it will throw an error. You know, MongoDB IDs are always, they are prefixed with an underscore. So we're mapping this, the ID that will be generated, they are mapping it to this ID. We want to use MongoDB IDs, not this ID in this very thing here. So come here, we delete our migrations. MongoDB doesn't use migrations because it's a document database and not SQL. We delete the database like so. And then we'll come here in our environmental, but then we'll set our database URL to this. Okay, now we'll go back in production, add variable, database URL. Then I will set it to this. Like so. MongoDB connection will work a little differently with serverless. To avoid box connection should be established before the serverless method. I don't worry about that. That is with Mongoose save. Then we'll come down here, we'll stop our server. You see npx prisma db push. You know, if it's SQL, you are using SQL. Okay, npx prisma db push. Okay, and we're having an error, invalid, and what argument was produced, database was defined in the connection string in database to the document. Well, string is invalid. The provided database string is invalid. Okay. I don't know what's happening, but then why does it say it is invalid? Arguments database must be defined in the connection string. Okay. Database URL will be. Why does it say it's invalid? Let me make it a string and then see what we got again. Okay, so at this point, oops. At this point, let me do something like this. Today is like a debugging session. It's all part of learning. So yeah, I've got the database name, I think. Okay, here we have login. I believe we all know MongoDB Atlas, so I don't need to talk about this. We all know MongoDB Atlas. So here, test projects. We hit connect, we hit drivers, and then we come down here. We copy this. Okay. I think what you're saying is slash, let's say, KodeCamp task manager, like so. And then we remove this string. And then we npx prisma db push. No. Okay, so now I'll come again, copy this, bring it down to our env file, and then paste it here. Then the password. Then slash the KodeCamp tax manager. There's the database name. And then we'll run it again. In case okay, in some case, certain characters must be escaped. Oh, okay. I think there was an error in our password. Okay, so now it's working and we have applying the following changes. Your database indexes are now in sync with your Prisma schema. Okay, that's sweet. And then let's go back to our Prisma. This thing, and then refresh. Dismiss. Okay, I think we close it because we've changed database. Okay, and it's not running npm run dev. Okay, Postgres is an SQL database. MongoDB is no SQL database. Or then maybe in our subsequent class we'll discuss about that. For now, sure, unable to run script. MongoDB task for many dictates. Okay, let's leave it that way. For now, let's see what we've got. Task, and then post, and then body. So in the body, we've got title of song, then description of some title, and then we send the request. Created. It's taking a bit longer. Look at the MongoDB ID. It does not have what do we call it? This is the MongoDB ID. Let's just leave it like that. So now what I will do is come here in an environmental variable, copy this database URL, see like so, then come down to variables and then change it here. Like so. Okay, so now I will come here, Control C, clear, git add, git commit, like so, and git push. Okay. Now once it's ready to be automatically, let's check deployments. 2 deployments. This one is pending. The one we just added, I think, it's not active. Then details. Let's see the details of the deployment. Prepare boundary inspector. Okay, now let's overview. Where is our application? Let's refresh it. We're still getting the same error. Type error, rest status not a function. error handler. Yeah. Error handler JS 969 status code internet server error. Okay. And okay, I think it's tasks, not tests. Tasks, not tests. Like so. Okay, Prisma tasks find many error occurred during query execution. But okay. Now, working with Prisma in production is another problem. So let's come here. Okay, so in our package JSON, we'll do something like in our start command, you see npx. But before that, let's do something like npx Prisma generate. Okay, now I think we're good to go. Git add, git commit, fix to, and then git push. Sorry. I think today's class is a bit boring. Okay, now let's run the command again. Git add. Okay, git add, git commit, and git push. Oh, it's true. Okay, I think we've saved it now. Package JSON. Git commit. git push again. Okay, so now let's check for deployment. It will be automatically deployed. Deployment. We have 4 deployments. The last one. I think it's done. The logs. Let's view the logs. Let's refresh this. Then monitor the logs. I think there's a problem with Prisma here, and then error, the application failed to start for more details. Okay. What we'll basically do is, I think, npm run start. This is the problem with serverless functions. All these cyclic and Vercel, all those are the serverless function hosting services. And this one is taking a little bit of time. So let's see. Get 500. Okay. And after checking this, I think we called it will be the end of today's class. Maybe in our next class, we'll continue our debugging and then our application deployment. But then let's see what's happening here in our local development environment. Okay, console is not defined, and that is where our error is coming from. Okay, but for now, I think we've come to the end of today's class, and in our next class, we'll know what our problem is. It's the console, and then I'll explain what Prisma generates, what it does, and why we need it to generate it before starting our application in production. I think that's all for today. Thank you all, and we've learned a lot. In our next slide, we explore how we can host our application with serverless functions, how to configure Prisma to work properly, and all of that. Thank you, and I will see you again on Tuesday and on Tuesday, we're going to be touching a whole lot of advanced things because we go faster on this and then we jump to the next topic online. Thank you.